is 192.168.1.2. But there seems to be no exit interface at the back. For some other routes, there is an outgoing interface behind them. And there is no outgoing interface behind this. If there is no interface, how to forward this route? This involves a function. Route iteration. When the router queries the routing table, it will have a static route addition table principle. The address of the current next hop must be guaranteed. Can be successfully reached through an outgoing interface. The reason why a static route can be added to the table. First of all, make sure the next address of the static route you wrote can be reached through the local outbound interface. Let's keep looking here. I just wrote a static route. Go to 1.1.1.1 next hop. Then you have to guarantee such an address. It must be reachable in the routing table of this device. Then write this static route will appear in the routing table. Let me explain to you how to measure whether the next hop is answerable. Just to see if there is a local route to the destination network segment. If there is a local route to the next hop address, then it means that the next hop is reachable. Now make sure that this route is reachable. To add to the routing table. How to ensure that this routing can reach you? There must be a local route that can reach the network segment of this address. Just because there is a local direct connection is 1.0. R1 can find this 1.2 through this direct connection. Then you write the route to which network segment. The next one is 1.2. To take effect. Otherwise it won't work. For us now. You tell me to go to this device in the future. You want to come here. But if for my local, I have no idea how this device works. Then you tell me. Go through this device to the following device. It's pointless. I mark it. 1, 2, 3. You tell me now. If you want to go to 3, you have to go to 2. Then I need to know how to get to 2 locally. If I don't know how to get to 2 on device 1 now, it doesn't make sense for you to tell me to go 3 and go 2. That is, you want to write this next hop now. Then the local must be able to reach this next hop first. I can't say that I can't reach this place. You tell me to give it the data. I can go to the network segment behind it. It doesn't make sense to me. So this is called the addition table of static routing. Measure whether the next item is reachable. Check if there is a route to the destination network segment. Reachable. Next hop address can be found through a route in the routing table. So please pay attention. Since I go to such an address, can be found through a local route. So since this data is going to be sent to such an address, then I would use outbound interface of such a route as the outbound interface of this route. This thing is called routing iteration. I want to go to 1.1 now. I'm going to go to 192.168.1.2 first. Then if you want to go to 192.168.1.2, it is on the 192.168.1.0 network segment. This data should be sent out from the 00 interface. That means, if I want to go to 1.1.1.1 in the future, data should be sent from here. Because the next hop belongs to this network segment. Go to this network segment and send out from the 00 interface. So in the future, go to 1.2 and send it like this. Although it is not written, but it's actually in this position. Look for this outgoing interface locally. The iterative function we call routing. Although there is no outgoing interface. But in fact, when forwarding, there are. That is, the process of looking for the outgoing interface of the static route locally on the device. We call it route iteration. Because we are now. I don't know how the outbound interface of this route should be filled. So we need to query the local routing table for other related routes. In this way, the process of determining the outgoing interface is realized. We call this iteration. That is to say, as long as the final data can just reach such an address. We just said, preceded by O stands for OSPF. But what we are actually talking about today is S. Static. So in this routing table, you see the ones that start with S. It means that this one was written manually by me just now. This C stands for connected. How did this direct route come about? Everyone can see. I just did not configure this. But it is generated in the routing table. I only configured a 1.1. So what's going on with this? As long as the interface of this router configured address plus mask, and I now enabled no shutdown for it, the interface starts working. Then a direct route related to it will be formed. And this interface will be used as the outgoing interface. Look at this picture. Now R1 this device. We give it the 00 interface. Configured an IP is 1.1. Then a 24-bit mask of 1.0 will be generated. Because it is a 24-bit mask. A route associated with it. And the outgoing interface is the local interface. This is called direct routing. Well, I have already told you about the conditions for its generation. First, the physical state of the interface is up. And after allocating the IP address, you have to manually no shutdown on the list. That is, the direct route is formed based on the information of the network segment connected under the current interface. Let's talk about the last one. There is an L here. L is called local routing. That is, what interface is configured on this router. Then the IP of this interface. A 32-bit host route will be generated. You can see it here. This is called host routing, also known as local routing. Its presentation in the table is L. Actually, it is also a direct way. You will find that what is written behind it is the same. This is my device direct connection. It's just that the network segment is called direct connection. L is called local. But in Cisco, it will have a distinction. This is all related to the IP allocation of this interface. Only represent this one host. The most accurate 32-bit mask. This is the host route. Finally, let's do an experiment. This is a basic configuration. This is 3 devices. Open them. Use static. Then let them communicate with each other. Let's do some basic configuration first. Remember how the PC is configured? We configure it with an IP address. 192.168.1.100. This is PC1. Then we will configure its mask later. That is 3255 and 10. 24-bit mask. Then configure a gateway. I have marked the gateway here. 192.168.1.254. PC2 is the same. 192.168.2.100. Then configure the mask. Then configure the gateway. 192.168.2.254.